Hi, welcome to our basic VLSI series, part 1, where we'll be converting this Boolean expression to a CMOS switch circuit. So here's the equation from earlier. So we're using this PMOS and NMOS symbols to build our circuit. Now, the way to do this is, first of all, you must have an equation that is already inverted. That means in full. That means it's a single bar across the entire expression. So if you have an expression that is not like that, you first need to convert them to be like this. So you could use the Morse theorem, etc., various Boolean algebra to convert it. So in our case, we already have the equation in the correct format. So the way we construct our CMOS circuit is we have a look at the expression without the bar, and we build the NMOS side first. So wherever there's an AND, that means we have to connect an NMOS in series. Wherever there's an OR, we have to connect the left and the right side of that OR in parallel. So let's proceed to do that. So let's start with an NMOS. So this is going to be our A and B. So A and B means they need to be connected like so. All right, we have a D and E that is also ANDed, so there must be a D and E somewhere that are ANDed together. All right, so that's our D and E. And then there's an F that is in parallel to our D and E. So we'll have an F that will be in parallel to our D and E. And then there is a C that is in series with the bracket. All right, so there will be a C that is in series with the bracket. So I'm just going to put it up there. All right, so we now have an A and B. Yeah, that's A and B. This is our A and B, all with everything on the right. So which means that this side will be in parallel to the right hand side. So let's just connect up all the wires and put them closer together. All right, so at the bottom of our NMOS network, will be our ground or VSS at the bottom. So right now that we've done the NMOS side of the circuit, so let's do the similar thing for the PMOS side. Now, for the PMOS, it is exact opposite to what is done in NMOS, meaning that wherever you have an AND, it is a parallel connection, and wherever you have an OR, it is a series connection. So let's just do that for PMOS. Alright, so we need to add a VDD on top of our PMOS network. Okay, so now once we have the both the PMOS network and the NMOS network together, we just need to combine the two to form the entire CMOS circuit. Alright, that's the end of our design for the CMOS switch circuit, where you have the PMOS network at the top and the NMOS network at the bottom, with Z as the output of the interconnect between the two networks. Alright, so if you have any questions, please put it down below. Share if you like this. And see you guys in the next part.